How we doing today there, my physics friends? Yeah, I know it's cheesy, but whatever. Uh, Today we're going to be talking about one simple question. We're going to be talking about what is energy. Okay, so that's the big question we want to ask today. So what is energy? By definition, what is energy? Well, let's start first with the definition itself. Let's start with what energy actually is by definition, which is the ability to do work. That's what energy actually is. We think of it in the terms of we plug into the wall, that's energy. We get up in the morning, that's energy. We drink some coffee with some caffeine in it or soda, there's energy there. And yes, this is true, but the basic physics definition is right here. It's the ability to do work. So, if we take this a little bit farther, we have a new word here. We have the word work. Well, what does work mean? Okay, and the physics definition for work is quite simple. It's actually how far a force moves an object. And this can be a large object, a small object, microscopic. It can be an electron. It can be a proton. It really doesn't matter. The case is how far work in the terms of physics is how far a force can move any object. Now, we'll talk about work a little bit more later, but for right now, I just want to talk about energy. Okay? So, let's go ahead and let's talk about energy in this case. So, the main thing you need to understand about energy is that there are four types. Okay, so there are four types of energy. Okay, so let's differentiate these in colors. So type 1 is what we call mechanical energy. Okay, so mechanical energy is the first type, and we'll switch colors. And the second type of energy is called thermal energy. And we'll switch colors again. For third type of energy is called electrical. And the fourth type is called electromagnetic energy. Now, in basic physics, high school physics, you're going to be dealing mostly with mechanical and thermal. Electrical energy does come in later when you deal with electric fields and things like that, and then magnetic does come in later. But for right now, as we're just starting with energy, we're going to look first at these two right here, mechanical energy and thermal energy. Okay? So, now what are these? Well, quite simple. It's actually quite simple, really. Mechanical energy is the movement of large things. So think like a car or a ball or a box or a bat or a person. We're moving macroscopic, large objects. Okay? Thermal energy is basically the movement of small objects. And specifically, we're talking about things like atoms. Now, we know that the more movement something has tends to be the warmer something is, hence why we have the word thermal. So the more that an atom's moving in this, or the more thermal energy that an object has, the more atoms are moving in that object, the more heat it has. This is the one we can actually feel. Mechanical energy is one that we can see easily. Thermal energy is one that we can feel. Electrical energy, it's still the movement of things, and you're still dealing with small objects, but it's specifically the flow or movement of charges. So think electrons and protons. And then electromagnetic energy is the movement of photons. In the modern physics sense. It can also be referred to as disturbances in magnetic fields. So there's that there. But we're not going to worry about that one too much right now. We're just going to focus on these top two, the mechanical and the thermal energy. So now that we have these four types of energy, we can actually go through and classify these into two other types. So you have these four types, and in each of those four types, you have these two subtypes as well. So when you look at mechanical energy and thermal energy, they both have these two subtypes that we're going to talk about, but these two subtypes don't tie into each other directly. So each one of these has the same two subtypes. So if we go, these two subtypes are actually quite simple. You have what's known as potential energy, and you have kinetic energy. Now remember, energy is the ability to do work. So what that means is that can actually be used when we actually look at the definition of these. Okay? So let's start with the one that's pretty much already known, kinetic. We know what kinetic is because if we remember back to kinetic friction, it's the friction when things are moving already. So that means kinetic energy is the energy that something has when it's moving. Potential energy is when it's not moving, but we need to be a little bit more specific on that. It's actually when the energy is stored. So let's take this in. Let's take a situation where we can actually look at this. So let's say we have a parachute. So here we have a man, and he's parachuting. So he's got the lines, he's got parachute, and he's falling down. Okay? And the ground, obviously, is way down here. Now, when he's way up here, he has a lot of potential energy. He has the energy of that is stored. That energy is stored in the form of gravity. Okay, and where he got that energy from, we'll talk about here in a minute. But he has a lot of potential energy. So he has a lot of energy that's stored by him being up so high. As he falls, that stored energy is getting transformed, it's getting changed, it's getting turned into kinetic energy. So as he falls, he starts to speed up. Obviously, the parachute's going to slow him down, but he starts to speed up, and that's going to change the potential energy into kinetic energy. If we were mean, and we go through and we just say his parachute went away, let's say it broke, and he didn't have a backup, bad idea, then he would fall, and he would keep speeding up, keep speeding up, keep speeding up, keep speeding up. So his speed would get greater and greater and greater and greater until he hit the ground. So all of this potential energy that he has as he's all the way up here at the top would get transformed or changed into kinetic energy, the energy of movement. Okay? So if we take that and we actually talk about that, it brings up the next topic, which is called the law of conservation of energy. Now, this simply states that energy cannot be created or destroyed. It merely changes forms. So what that means is, it doesn't matter what happens, but that energy will always be there in some way, some form, in one of the four forms that we have: mechanical, electrical, electromagnetic, or thermal. It'll always be in one of those forms. So let's take a ball. And let's say this ball was dropped. Let's do better than that. Let's say this ball was dropped from the top of a building. Now, as this ball is way up here being held, let's say it's being held, it hasn't been dropped yet, it has a great deal of potential energy. It has a lot of ability to do work. In other words, ability to move. And that's what potential energy is. It has the potential or the ability to do all this work. Once it's let go and it starts to move, that potential energy is going to be changed into the kinetic energy, which is going to make it move, like we had in the last example. But think about it like this. Let's say this ball was a bouncy ball, one of the super balls. Well, when this ball hits the ground, it's going to bounce up. So this ball goes all the way down to the ground and it hits. Then it's going to bounce up. Is it going to bounce all the way back up to the top of the building? No. It's probably going to stop. Realistically, it'll stop somewhere much lower. But let's just say, for the sake of argument, that it stops about 3/4 of the way back up. Okay? Well, what happened? All this potential energy got transformed into kinetic. How come that kinetic didn't get transformed back into potential when it came back up? That's because some of the energy was lost. Well, we just said here that the law of conservation of energy means the energy isn't lost. It doesn't go anywhere, which is true. It stays in a certain, it stays there. It's still there. It just got changed into something else. When we drop this ball is going to be experiencing air resistance. It's going to slow it down a little bit, but more importantly, it's going to take away some of the energy. When the ball hits the ground, it's going to take away a little bit more of the energy. But where did it go? That's where we have to turn around and we have to go back and we have to look at these four types of energy. We know that mechanical energy is the movement of large objects, so a ball. Electrical energy, flow of movement of charges, really doesn't fit. Neither does electromagnetic, because we don't have any lighter magnetic fields. But thermal energy does happen here. Because we talked about thermal energy is when you have movement of atoms. Well, when this ball hits the ground, it's going to actually give off a little bit of thermal energy. It's going to actually transform some of this kinetic energy that it has into heat. You know that when you bend a paper clip or something like that, you move that paper clip back and forth, back and forth, back and forth, back and forth, and it turns into thermal energy. It heats that paper clip up. Well, the same thing's going to happen here. The reason why we don't notice it is because the ball, if it's small enough, there's not a lot of heat that it actually generates, and you get into specific heats and things like that. But what you have to understand is this energy does transform. It turns from potential to kinetic, back to potential as it goes back up. Some of it is lost, and it's lost in the form of thermal. Okay? So how can we represent this graphically? So that's the question. So let's take a look at this one here. Let's go ahead and let's look at this one. And let's go ahead and get rid of the law of conservation of energy here. We don't really need that anymore. We know what it is. So this is gone. And let's take this scenario. Let's take the ball being dropped. And let's set up a few spots. So let's ignore the bounce back up. Let's set up a few spots here. So let's say we have 3 points we want to look at. We want to look at up here, right before it's dropped. Let's say about halfway down, and let's say right when it hits the ground. And I want to represent where all the energy is found in this. Well, one of the best ways to do this non-mathematically, just graphically, is with a pie chart. Okay, and we can probably do better than that. So, at this point, no movement has happened, hasn't started to move, hasn't started to drop, it's just sitting up there. It has the ability to move, it just hasn't moved. So what we're going to say is 100% in the entire pie chart here, this is all going to be potential energy. Because it has the ability to move, there's no movement that's happening, it hasn't given away any of this energy or anything. And that fits. Well, once we get to the second stage, about halfway down, well now, does it have as much potential energy as it did up here? No, it's much lower. So it can't move as far. So what we're going to have here is we'll have about half of this is going to be potential energy, and the other half is going to be kinetic energy. Now, air resistance isn't going to take too much at this point. It's not going to have that much of an effect in this situation, but we will bring in thermal energy here in a minute. So here we have the bottom when it hits the ground. Now, at this point, the ball gets deformed, it hits the ground, it starts to bounce back up, and we have all those things happening. So the question is here, do we have any potential energy? Okay, right before it hits the ground, we have no potential energy. We're going to, let's actually say that. Let's say right before it hits the ground, because when it hits the ground, then you're dealing with elastic energy and things like that. Let's not get into that yet. So right before it hits the ground, where has all the energy gone? Well, is it potential anymore? No, that's pretty much gone. So the only energy we have here at this point is we have kinetic energy. Now, if you wanted to be accurate, you would probably have a small little slice of thermal energy. But in this case, since we just have air and it's a small little super ball, we probably don't need to worry about that too much. So let's go ahead and let's just not include that. So we'll just say kinetic energy. Okay? So that's kind of the basics of energy that we have to deal with here. And there are other types of energy that we will be dealing with, but this is the start of it, and we'll expand on it more as it goes. If you have any questions, be sure to leave them in the comments below, and I hope this video was helpful as understanding what the energies are.